I like that one.
Good choice, sir. Give me a moment, sir. You're all done, sir.
I'd like to see what's behind that one, please.
What are you talking about, sir? You're all done, sir.
What's up, Code Crew? In this video, we are going to be going over exactly how we can build a password manager using some encryption and a cat picture. As I was creating this demo, I realized there was a lot of things that seemed random and out of the ordinary, and I felt it was necessary for me to create that video so that you can actually see how these pieces are put together. So we're going to go over into a high-level view, and then we'll step into the technicals with Linux. So let's go ahead and dive in. Now, a little bit of background information that you're going to need to have for this is there are 3 types of authentication factors that we have. We have something that you know. This would be a password, for example. Something that you have, which would be an authenticator code on your phone. And something that you are, which would be biometrics, like your fingerprint. So in the video that we just saw, something that you know, the password was the word kitty. That was the phrase that was used to show that there was actually an item behind the painting. The something you have was the picture of the 4 dice that was taken. So now that we have some understanding of that, let's go into exactly how a vault is created for this type of project. So this vault that we're going to create will be a piece of data locked behind a cat picture. And there's going to be 2 factors that are going to be needed to extract the secret from that photo. Okay, so let's go into the process of how that's going to go down. So here is the user, and the user has some secrets. Okay, now the user is going to go and pick a photo to put those secrets behind. But the user doesn't want to just put the secrets in plain text behind the photo. To add that second layer of protection, the user would want to lock up that data using something what's known as AES encryption, AES 256-bit encryption. So the secrets go into this encryption algorithm. The algorithm uses the key to jumble up all of the information, coming out with encrypted data, which would then be safely placed behind the cat picture. Okay. Now, when we talk about AES 256, there are some points that we have to go over to truly understand this, okay? So first of all, AES 256, the Advanced Encryption Standard, is a symmetric encryption algorithm. This means that the key that's used to lock the data is the same key that's used to unlock the data. And because we're using AES 256, this means that there is a 256-bit key that's used to lock that data. So if you were using AES 128, that would mean you're using a 128-bit key. Okay. Now this raises the question, where does the key come from? Now we have 2 options for the key, okay? First, we could generate a key, right? We could just generate a key, but this would also require us needing to generate something what's known as an initialization vector, which is already making things kind of complicated, right? Just listen to that name, initialization vector, right? The other way that we can create a key is with deriving a key from a password. We would be using a password-based key derivation function. Way easier, okay? Now, you don't want the password to derive the key to be kitty, right? You don't want it to be kitty because then you're just using the same password twice, okay? So we need a different key. We need a different password to derive that key. Now, notice, even if we were to just generate a key or derive a key from a password, both of them require us to store that information, right? If I were to generate a key, I would need to store that key for later so that I can decrypt and unlock the information. And if I were to use a password, I would need to store a password so that I can derive that key from that password later on in the future. So both options here require us to store this information. So this poses a challenge, which is how do we make sure that only authorized users can have access to the stored key? Which is basically asking, how do we protect the stored key? So to do this, we have to do 2 things. First, we're going to mess with some file permissions. Okay, this is more technical, right? We want to make sure that only the root user can read the stored key or password. Okay, only the root user can read it. The second thing we'll need to do is create some type of program that will check a user's one-time 6-digit code before accessing the stored password. Now, as we saw in the video, the password kitty was used to reveal the locked up data. To actually get the key to unlock that data, there needed to be a check on the 6-digit code. Okay, so again, we're going to need a program that will check the user's 6-digit code before accessing this stored key or password. Now, there's a couple of things we should note here. Okay, the user must be able to run the program as sudo, right? Because only root can read the key. If a non-admin user were to run the program as a non-admin, they wouldn't have the necessary privileges to access the key. So we need to make sure that the user can run the program as sudo, but at the same time, not be able to access the key or the password without the program. So this is great, but it also raises a new question, which is, where does the temporary one-time password come from? So as we saw in the video, the man in black, or the man posing as root in that video, pulled out some dice and rolled some dice. That was what we call the shared secret. Okay, so the 6-digit code comes from the shared password plus time. So when the initialization of the vault happened, the dice were rolled, 4 numbers were shown. The user takes a picture of those 4 numbers. When the user comes back to present a 6-digit code, the user used those 4 numbers from the picture on their phone plus the 2 digits of the minute on time. That's like the most simple way to put it. It's a lot more in depth than that. It uses some hashing, but you see the idea. Essentially, the 6-digit code comes from a shared secret plus time. Okay. Now this poses a new challenge because now you need to store the shared secret, right? If you want to calculate the code from a shared secret later on in the future, you have to hold on to that secret so that you can calculate the same code again. Okay, so this is the problem. How do we protect the stored shared secret? Well, when we give the shared secret to the user, they're simply putting it onto their phone, right? Like in the real world, you would scan some QR code in your authenticator app, and then it just saves it into your phone. That's why if you lose your device and if you don't have a backup code, then your 2FA needs to be reset. However, for the program, we need to do a couple of things, okay? For the service that's looking to store the shared secret, they will need to do the following. First, they will need to make sure that only the root user can access the shared secret. Second thing they'll need to do is with that same program that's being used to check the 6-digit code, that program will need to run as root so that it can read that shared secret to calculate the 6-digit code. Now you'll notice that root has some responsibilities here, right? One of the things that they'll need to do is create the password to be used to create our encryption key. Remember that password-based key derivation function, right? We're going to need a password that's created from root. And again, this password that's being used to derive a key is only readable by root. Another thing that root will need to do is create a shared secret. They'll need to roll the dice, so to speak. Once root has created this shared secret, root will then need to share this secret with the user. And then typically what happens after that is the user will then send the 6-digit code as confirmation that the secret has been received. Once all those things are done, then the program, assuming that the 6-digit code was correct, will be able to access the key to lock up the secret data. The user will then have encrypted data to embed into the cat photo with the master password of Kitty. So your first factor of authentication is the password, and then your second factor of authentication would be your 6-digit code. So this is how the decryption flow would go, okay? So you have the user who is looking to pull out their embedded data from the cat picture. So the user provides their master password. The data that's locked up is then given to the user. The user now needs to unlock this data. So they'll go into their program that's running as root, and they will provide their 6-digit code. If the code is invalid, the program exits. The data is not unlocked because access to the key is not available. However, if the 6-digit code is correct, the program running as root will then be able to access the key to unlock the data and provide the clear text of the secrets, leaving the user to do whatever it is that they would want with that data. I'll be honest with you and tell you that coming up with this entire diagram and this solution did take some time. It did take a few tries to get into this. And now that we see these challenges, let's go into how exactly this would go down on a Linux machine. All right, let's go ahead and get started. Let me go ahead and pop open a terminal, right? And we're going to want to create a non-admin user. So let me do a sudo add user. I'll call it non-admin. Let's go ahead and just go through the flow. All right. Let me go ahead and switch over to non-admin and notice that they do not have any sudo privileges. Okay. User non-admin may not run sudo on this machine. Okay. So let me do a nano creds.json. You can use whatever editor you want. Feel free to use Vim if you're one of the cool kids. And I'll go ahead and put this as youtube.com, right? We're just making a JSON object. We have an object with a key of youtube.com, which has a value of another object containing our credentials. I'll put in our coding for the username. Let's go ahead and put a password. I'll put please subscribe. Go ahead and close that object up. And there is our JSON object. So the next step for the user is to go ahead and get a cat picture. Okay, so I actually have this quick little script that will download a cat picture for you. All right, and now we have our cat.jpg. Let me go ahead and check that file header. And it is in fact a JPEG. Let's go take a look at it over into our file explorer. Let me come into other locations, computer, home, non-admin. And here's our cat picture. My man's living the life over there. Really taking a healthy positioned nap. So now that we have our cat picture, we have our credentials, right? We're looking to encrypt or lock up this data before we use our stego tool to hide it inside of the cat picture. So to do that, we need an encryption key, which must be created from root. So let me switch over to root real quick. And let's go ahead and echo. This is the encryption password, 123. And we'll put that into a hidden file, encryption.key. We're also going to need a secret for our TOTP. So to do that, we're going to need to grab 20 random bytes. And we will need to encode that into base 32. All right, so let me go ahead and put that into a hidden file called TOTP secret. Now what we'll need to do is create a program that will check the 6-digit code based off of the TOTP secret. And then if the code's correct, access the encryption key to encrypt the data. So we're gonna need a script of some sort. Let me go ahead and make one. I'll call it encrypt decrypt.bash. Put our shebang, and let's go ahead and define some variables first. Let's go ahead and get our encryption key. So that'll be coming in from, let's use absolute pass. And then we're gonna also need to read our TOTP secret, which will also come from the root absolute path, okay? We'll also need to define a valid code, okay? So let's talk about how we grab a valid code, okay? So coming over into a new terminal, okay? Let me switch over into root for you guys. To do this, we're going to use a command line tool that's used to generate and validate one-time passwords. It's called Oath Tool, okay? Gonna wanna go ahead and install that. Just popping into the manual of Oath Tool, you can see that this is a open authentication one-time password tool. So you use your Oath Tool to create a one-time password, taking in a secret that's base 32 encoded. So let's go ahead and put in one-time password secret. So if I were to wait 30 seconds, there you see the code is now different, okay? So root now needs to share this secret with the user. So typically you use your phone to scan a QR code. So we can use a tool called QR encode. Let me go ahead and install that real quick. Using our QR encode, we're looking to show a QR code on the terminal. We're just gonna use ANSI UTF-8. Go ahead and put in this path for non-admin containing a secret of our TOTP secret and an issuer, let's call it CatPass. All right, here's our QR code. Let me go ahead and scan that real quick. All right, so you can use any authenticator app that you would like. I'm using this app called 2FAS Auth. I'm just gonna go ahead and click pair new service. And now it's asking me to scan a QR code, right? Oh, it says this QR code does not work. I actually see the issue, syntax mistake. Let me go and put that. It's OTP auth, not OTP. Let me go ahead and try that again. And it worked. Now I have my 6-digit code for cat pass. Okay. So now that TOTP secret is stored on the phone. That is equivalent to the user taking a photo of the 4 dice. Now the user is able to generate valid 6-digit one-time passwords. Let's go ahead and put in our variable finally for the valid 6-digit code. So actually, let's just check that so you can see it for yourself. Our oath tool to generate that TOTP, taking in the TOTP secrets. And there you see it's a 600-717. And then on the phone, oh, actually just changed. What is the chances? So here you can see it has a 240-793. And then on the phone, 240-793. So this is working. So now we have a command that we can use to check for valid codes using our TOTP secrets. We will need to then check the user's TOTP, right? So we would echo, please enter your one-time password. And then we would want to read that as user code. And then we'll do a simple if statement to check. We'll say if the user code does not equal the valid code, then echo invalid code, and then we'll exit. Otherwise, we can proceed as usual, okay? So this would lead us into the crypto operations, right? So let's talk about this usage. How is this tool going to be used? So let me go ahead and put this up here. Usage, of course, you're going to have to call the script name, and then the user will specify whether they want to encrypt or decrypt, and then the file that they're looking to perform that cryptographic operation on. So we'll have here then, if the user's first argument is equal to encrypt, then we would encrypt the data. Let's talk about that a little bit, this encryption of the data. On your Linux machine, you have a tool called OpenSSL. Let me go ahead and put a manual on that. And OpenSSL is a cryptography toolkit. It's used for various cryptography functions. If you just run OpenSSL, you see that there's 3 types of commands. There are standard commands, there are digest commands, which are used for like hashing, and then there are your cipher commands, which are used for encryption, decryption. This is where we want to be. And it even says here, see the enc command for more details. So if you were to do a man on OpenSSL encrypt, you actually have a whole manual page just for the encryption. And this one's really cool because if you go down a bit, you'll even find examples of how to use this tool, right? You can just copy paste these, put in your own files or passwords to be used, and ta-da, cryptography. Okay, so this is where you would find out how to use this tool without ChatGPT if you're still one of those people, okay, which is great. Okay, so if the user using this tool is looking to encrypt their file, then we would use OpenSSL to encrypt using AES-256 on a password-based key derivation function, taking in the file, and then let's go ahead and save it into a new file. It'll just be the same file name, but with .enc at the end, a .encrypt at the end. And then we will also need to pass in the password. Remember, that would be our encryption key, okay? And just remembering the syntax from what I saw on the manual pages, it'll just be like this, okay? Now, else if their argument is decrypt, you know, actually go ahead and put these in quotes just to avoid any funny business. Now, else if they're looking to decrypt, then we would use OpenSSL, one of their encryption ciphers on AES-256 to decrypt using password-based key derivation function, taking in the file and outputting that file, but without the last 4 characters. Okay, put that little syntax in to accomplish that. And then we would need to pass in that password because it's using the same key to lock and unlock the data. And then that's it. To make it a little bit more user-friendly, I'll even echo for the encryption successful, and then for the decrypt. All right, let me go ahead and save that. And before we do everything needed to allow non-admin to run it, let's just do some tests, yeah? So I'm gonna echo a test secret into test.txt. Okay, so now let's go ahead and run our encryption script to encrypt on our test.txt. Let's enter a wrong 6-digit code, and it is invalid as expected. Let's go ahead and run it again, this time with the proper code. I have a 029521, encryption successful. Let me go ahead and list out. And there is our test.txt.encrypted. Let me go ahead and cat that open. And there you see our encrypted data, which has even been salted. So now let's go ahead and test our decryption option. Let me go ahead and remove test.txt. So I only have the encrypted version. Let's go ahead and run our script with the decrypt option on test.txt.encrypted. Enter the one-time password. I have a 061231. All right. Looks like I didn't get a echo of decryption successful. Then let me go ahead and try it by itself. So open SSL, encrypt, using AES-256, looking to decrypt with a password-based key derivation function, taking in our test encrypt, calling it out test.txt with the pass of our enc.key. And there it is. It worked that time. So it's something inside of our script that's causing this to happen. Oh, it's because it's really simple. It's because I used the second argument instead of the first argument. Really small, simple mistake. Let's go ahead and try that again. Let me remove test.txt. Okay, let's clear out. Let's run that decrypt option one more time. Let's enter in our 6-digit code. I have a 262847. Decryption successful. Let's go ahead and cat that open. Test secret. Boom, it worked. Let's go ahead and remove those test files. And let's check out the permissions on our encrypt decrypt script. And notice that there's no executable permissions for any of the types of users. For the owner, no executable. For the group, no executable. And then for everyone else, all the others, no executable as well. We will use a chmod of a 755 on that script. Now when we list out permissions again, notice that all user types can execute, right? Of course, the owner, root, can read, write, and execute, but everyone else can only read and execute it, okay? So now what we'll do is move the script into our user local bin. All right, this will make it accessible for non-admin. Now, notice if non-admin, remember that guy, the guy who has no sudo privileges, if he were to go and try to run that script on his credentials.json, there is a permission denied of accessing the encrypted key and its one-time password secret, okay? They would have to run this script as sudo, but they do not have sudo or permissions, okay? So let's go ahead and allow non-admin to run this script as sudo, and only that script as sudo. So going back into root, we will edit our sudoers file by running a vsudo, and we'll come down into the user privilege specification. And for non-admin, for all hosts, no password required, they will be allowed to run the encrypt decrypt script as sudo. Okay, go ahead and save that. And now when non-admin looks at their sudo privileges, they are now able to run the encrypt decrypt script as root, okay? Notice also, they cannot access the encryption key, okay? Even if they sudo it, they cannot access the encryption key. The only thing that they can run as sudo is this bash script that we created, okay? So let me go ahead and sudo encrypt decrypt, specifying an encryption on our creds.json. We'll enter in our 6-digit code. Encryption successful. And here is our creds.json encrypted. Let me go ahead and cat that open. Boom. All right. So now that we have that, we can remove the clear text version, and we can go ahead and embed this encrypted data into our cat picture, okay? So to do that, we're going to need a tool called steghide, which is a steganography tool. Pulling into the help page, you can see there's an example of how exactly you would embed your file into the cover file. Our cover file would be the cat picture in this example. So we do a steghide embed into our cover file of cat.jpg, and our embedded file will be the creds.json.encrypted. Specify the passphrase. This is the passphrase that's used to reveal the encrypted data inside of the cat picture. Just to follow along with our example, kitty, kitty. All right. And it is done, okay? These secrets that have been encrypted with our AES-256-bit key have now been embedded into the cat picture. Coming into our file explorer, other locations, computer, home, non-admin, looking at the cat picture, everything's the same. He's still sleeping. He's still adorable. Nothing to see there, right? Okay, so now that our secrets have been placed into the cat picture, we can remove our creds, and everything's done. Only thing left is the cat photo. So let's go over now how to extract it and then decrypt the data, okay? So we use our steghide tool to extract from our stego file of cat.jpg. Entering an incorrect passphrase cannot extract the data. With the correct passphrase, we now have our encrypted JSON credentials. Okay. We would then use sudo on our encryption decryption script to decrypt our creds.json.encrypt, entering a proper 6-digit code of a 921020. Decryption successful. And there are our creds.json. Let me go and cat those open. Awesome. And everything works. And with that, guys, I hope you had a wonderful time. Don't forget to tell all your friends, smash like, subscribe, and I will see you next time. Bye-bye.